Hello all, welcome to VJD Academy. This is Anil Kumar, Faculty of Digital Electronics. Today, I'd like to teach one more new concept called truth tables of Boolean algebra. Sir, we have seen in the previous lecture what are the possible number of Boolean algebra theorems and what is the order of minimization. Now let us try to introduce one more new concept called truth tables. Here, according to our syllabus in the previous lecture, I told you the possible number of topics in the Boolean algebra. Sir, this is what third chapter, or we can say third topic. Here, truth tables of Boolean algebra. Sir, truth tables of Boolean algebra, it is a very important concept and it is also having higher weightage in competitive exam point of view. We have two types of equations in this particular concept, and if you can learn, if you can understand, we may get question in competitive exam point of view. Let us try to understand what are the possible number of truth tables for the given number of inputs. Sir, I told you in the previous lecture, suppose here the examiner is asking you the number of input variables. Suppose the number of input variables are 2, let us say. If the number of input variables are 2, which are, we can say that A comma B, and if the examiner is asking that how many possible number of input combinations. If the question is asking like this, we know the equation is 2 power n. Here 2 power n is the possible number of input combinations for the given input variables. Sir, suppose here I would like to draw a table here to understand better. And now the second thing, suppose if the examiner is asking that how many number of possible truth tables for the given two or many or whatever the input variables. If the examiner is asking that how many possible number of truth tables, the question is asking like this. The equation is 2 power n. There is a difference between these two equations, sir. Here 2 power n is the number of input combinations, and the 2 power n is the number of possible truth tables. Let me draw a truth table here so that we will understand better. Suppose here serial number and then number of input variables. We can say input variables. Based upon these input variables, number of combinations, number of input combinations. So the equations will be 2 power n. And now let me take here number of truth tables, possible truth tables. Number of possible truth tables, let me take truth tables. So the equation will be 2 power n. So this is the truth table. Let us try to understand better so that we will solve whatever the question examiner is asking in the competitive exam point of view. Sir, here let me take different types of input variables, and then let us try to calculate how many number of input combinations and how many number of possible truth tables. Here let me take the first case. Here let me take here input variable is 1. We can say that is called A. And now here n equal to A we can say, which means n equal to A. Here we know that n equal to 1 because only one variable. So n equal to 1. Here 2 power n means 2 power 1. We can say 2 possible input combinations, which are, we can say 0 and then 1. And now here how many number of possible truth tables when n equal to 1. Here sir, when n equal to 1, we can say 2 power 1. Then here we can say 2 square. Finally, we have 4 possible truth tables. And then let me take the second case here. Suppose if examiner is giving that there are 2 input variables. We can say 2 input variables. We can say a comma 2 input variables a comma b. Now here n equal to 2 and now 2 power, we can say 2 power n, 2 square. Total number of input possible combinations are 4. We can say that 0 0 0 1 1 0 and 1 1. All these things we have seen in the previous lecture even. Now let us try to understand how many number of possible truth tables are here. N equal to 2, which means 2 power 2, we can say 2 power 4. Finally, we may have 16 possible truth tables for the 2 input variable. Sir, now let us try to understand the third case even. Here suppose there are 3 input variables which are a, comma b, comma c. And now here n equal to 3 and 2 power n, we can say that 2 cube, we can say that 8 input possible combinations 0 0 0 0 0 1 0 1 0 and then finally 1 1 1. All those things I told you in the previous lecture. Now let us try to understand how many number of truth tables are possible. Here n equal to 3 and then 2 power 2 and then power 3, we can say that 2 power 8 and then how many possible number of input truth tables, we can say that total number of input possible truth tables are 32. Here sir, this is what, suppose if number of input variables are increasing, number of combinations will be 16 and then here it will be, we can say 64 and then 128 like that. Sir, this is the way to understand, or we can say that this is the equation to understand number of truth tables possible for the given input variables. Now let us try to understand what are those 4 types of truth tables, what are those 16 truth tables, what are those 32 truth tables when we are giving different types of inputs. Let us try to understand. Now let us try to understand what are the 4 possible truth tables for the given input 1 variable, or we can say for 1 input variable how many possible number of truth tables. We have seen 4 are there, and now what are those truth tables? Let us try to understand. Sir, we know that here we have seen 7 types of basic gates. Out of 7 types of basic gates, only 1 gate is operating with 1 variable or 1 input variable. We know that gate is, we can say, NOT gate. Here this is a NOT gate which is operating with 1 variable. Sir, that is called A is a input. Sir, here the possible number of inputs, we can say, or input trials we can apply, either 0 we can apply or we can say A equal to 1 we can apply. Sir, here the output will become y equal to. Sir, let me draw a truth table for this one input variable. Sir, A equal to and then y is output. Here sir, we can apply 0, A equal to 0. Here the gate is producing 0, let us assume, and then when we apply A equal to 1, even then the gate is producing, the output is 0. Here when we apply A equal to 1 and then A equal to 0, whatever the input we are changing, the output it is producing, not gate producing always 0, which means this gate is acting as ground condition. And now let us try to understand the second possible truth table. Suppose this is a NOT gate. Let us try to understand here A and then this is Y. Sir, let me try to apply 2 input variables. Here A equal to and then A equal to 0 and then A equal to 1 possible inputs. Sir, the moment when I apply input 0, the output, let us assume 1. The moment when I apply input 1 and then output is 1. Here sir, whatever the input if I am changing, the gate is producing only output which is 1, which means the gate is acting as a direct connection gate. Direct connection gate, or we can say the circuit is short circuited, or we can say the gate is short circuited. Now let us try to see the third case here. Third case, sir, here third truth table. Here these two truth tables are possible, and now let us try to understand what is the third truth table is possible. Here A equal to 0 case and then 1 case. Here Y will become, when we apply 0, here it may produce 0 output. When we apply 1 as input, it may produce 1 as output, which means suppose when we changing input 0 and then 1, the output is producing as like input, which means the gate is acting as buffer. The gate is acting as a buffer. And now let us try to understand the fourth case, sir. Here suppose if I can take here A as input, now Y is output. Here A equal to 0 and then 1. These are the two possible combinations. Output is, when we apply 0, suppose if gate is producing is 1, and then when we apply 1, here the gate is producing 0, which means the gate is acting as exactly inverter. So these are the possible 4 truth tables or possible truth tables for the given input 1. Now let us try to understand what is the possible truth tables count when we apply input variables are 2. Let us take here 2 input variables, which are, we can say that A comma B are the 2 input variables. Then we will see here 2 power 2. Here the possible number of truth tables will become 16. Now let us try to understand what are those 16 truth table combinations. What are those 16 truth table combinations? Let us try to understand. Sir, here the moment when we take here 2 input variables, which means we may get 4 input combinations, which are here input variables are A, B. We know that here 0, 0, 0, 1, 1, 0, and then finally 1, 1. These are the input combinations. Now let us try to take here 16 truth tables. I just need to get here the moment when I give input A, B, I may get Y equal to 0. This is one truth table. And now the moment when we apply A and B as inputs, I may get Y equal to 1. And now Y equal to A, Y equal to B. This may be fourth truth table combination, and we can get Y equal to A bar, and now Y equal to B bar we may get, and now we can say that Y equal to A into B, and now Y equal to A plus B, which means it is OR gate, and now here Y equal to A bar into B, and now Y equal to A into B bar. Here we can say Y equal to A bar plus B, and now here Y equal to A plus B bar, and now we can take here Y equal to A plus B whole bar, and we can take Y equal to A into B whole bar, something like that. Likewise, we can draw 16 possible truth tables when we take here inputs are 2. Sir, this is what the truth table. We can say that here possible 16 truth tables we can draw, sir, when we get 2 inputs A and B as a input variables. Now we can draw the output may be here Y equal to 0, means when we take A, B, the output truth table may be possible like this, and then may be possible like this. Here we may get all A, which means variables of or input variables of A 0, 0, 1, 1, and now B means here we may get 0, 1, 0, 1, and now A bar means here 1, 1, 0, 0, and now B bar means 1, 0, 1, 0. Here A into B means 0, 0, 0, and then here finally 1, and now A plus B means here 0, 1, 1, 1, and now A bar into B means here A bar, and then we can say that B. So now likewise, sir, we can draw 16 types of truth tables for the two input given variables. Now sir, we know that here A into B, we can say that this is called AND gate. Now A plus B, we can say that this is OR gate. And now here there is another new term here. These are the two new terms, A bar into B and then A into B bar. When we get these type of combinations, this gate is called as inhibitor gate. This gate is called as inhibitor gate. And now there is one more combination here, A bar plus B and then A plus B bar. This is called as implication gate. These are the two sentences we just need to remember, and these are the two sentences I am introducing newly. Now this is called inhibitor gate when we are getting combination A bar B and then A into B bar. Now when we are getting the combination A bar plus B, A plus B bar, this gate is called as implication gate. Sir, this is how we can draw the number of possible truth tables when we are giving 2 or 3 or whatever the number of input variables based upon this equation. This is a equation very important to understand for solving the problems in competitive exam point of view. Thanks for watching. Please do subscribe.